In 1980, a private Japanese expedition funded by Nobuo Harada arrived at Colonia Airfield on Yap Island. The objective was the location, evaluation, and extraction of surviving Mitsubishi A6M Zeros. Time and access were the governing constraints. In 1980, a private recovery could still operate with minimal outside scrutiny, before Yap's preservation regime hardened into permits, restrictions, and prohibitions. The procedural stakes were dictated by the condition of the surviving material. They needed to identify viable target airframes among the decaying structures scattered around the perimeter. Most published accounts describe the expedition locating and securing 4 specific aircraft. Some references loosely speak of 5 wrecks, but the publicly itemized inventory most often resolves into 2 A6M2 Model 21s and 2 A6M5 Model 52s. Securing the selected Zeros began with a disciplined site survey. Colonia Airfield was a complex environment for forensic retrieval, and the team first had to judge which wrecks still held continuous structure beneath the jungle overgrowth. The decision point was unforgiving. Choose only what could survive being moved. The team could not extract random debris. They required contiguous structural sections capable of withstanding the physical stress of being moved. The selection prioritized aircraft retaining their primary geometry. Surveyors examined the alignment of the wing spars, the integrity of the center sections, and the attachment points of the empennages. The primary hazard governing this selection was the timeline. By 1980, these aircraft had sat exposed to the tropical environment for 36 years. 36 years of seasonal typhoons, high humidity, and heavy salt air creates profound degradation. The gap between their abandonment and this extraction window defined every physical interaction the team had with the wrecks. The expedition members were not looking at pristine artifacts, they were looking at compromised load-bearing structures heavily altered by the local climate. The survival of these specific airframes resulted from an operational quirk of the Pacific island hopping campaign. Yap was bypassed rather than seized and rebuilt, because standard procedures for clearing a captured airfield were never applied here, as the aircraft remained exactly where they were pushed at the end of their operational lives. This accidental preservation kept the wrecks on the island but guaranteed their prolonged exposure to the aggressive atmosphere. That exposure dictated the handling plan. After 3.5 decades in salt air, nothing could be assumed sound. Every move had to be controlled. The window for physical removal was narrow. In the years that followed, heritage protections on Yap hardened into a far more restrictive, permit-based regime. Whatever room private collectors once believed they had would steadily disappear. The standard operating procedure involved manually clearing overgrowth to establish a safe working perimeter around each of the 4 selected Zeros. They had to map the footprint of the A6M2 and A6M5 variants to determine the safest extraction paths to the port. The survey became a running trade-off between completeness and survivability. One wrong pull on a wing root, a spar, a bracket, could turn a recoverable section into scrap. So each call had to be conservative, evidence-led, and reversible, favor the wrecks that still held their geometry, and walk away from anything already past structural failure. The extraction parameters were firmly set. They had found their 4 targets, mapped the extraction routes, and established the baseline geometry of the surviving structures. However, visual inspections in a jungle environment only reveal a portion of the true material condition. The external assessment could not fully quantify the degradation occurring beneath the surface. The recovery team had successfully isolated the 4 Zeros, but the physical reality of the metal itself remained untested. The critical unknown at the end of this initial survey was the precise internal integrity of the alloy. What condition were these specific airframes truly in after 3.5 decades in a highly corrosive tropical salt environment? The geometry of Colonia Airfield defined the final resting place of its defending aircraft. During 1944, damaged Mitsubishi fighters were pushed to the extreme margins of the runway. This deliberate relocation created a boundary ring of wrecks. Yap Island functioned as a forward airfield site within the Caroline Islands chain. From late March and through the rest of 1944, the airfield was repeatedly attacked by United States carrier aircraft, and later long-range bombers including B-24 Liberators. The loss mechanics for these specific airframes were not characterized by high-altitude structural failure or high-speed ground impact. Instead, the loss was procedural and cumulative. Bombing runs cratered the runway and systematically destroyed the maintenance infrastructure. Supply lines bringing replacement components were severed. Without spare parts to repair battle damage or operational wear, the A6M2 and A6M5 fighters reached an irreversible threshold. Japanese ground crews executed a disciplined cannibalization protocol. They stripped the damaged airframes of usable engine components, flight instruments, and control surfaces to keep a dwindling number of remaining aircraft flying. Once stripped of their immediate operational value, the gutted shells were rolled into the tropical overgrowth at the edges of the active zone and abandoned. The neutralization of the base meant these airframes transitioned from frontline fighters to static wreckage exactly where they were parked. Yap stayed off the invasion list. Plans to seize the island were shelved, and United States forces never took and operated Colonia Airfield during the war, an operational omission that froze the site in place. Elsewhere in the Pacific, captured runways were rebuilt under a single priority: clear obstacles fast, push wrecks aside, and get aircraft flying again, with methods shifting by terrain and urgency. The bypass paradox prevented this standard mechanical destruction. The wrecks were preserved by isolation. They remained untouched by heavy earth-moving machinery, resting undisturbed in the exact configuration of their 1944 abandonment. This lack of physical disturbance created a pristine surface distribution of debris, but it also imposed a unique set of environmental variables. The aircraft were left resting on soft tropical earth, without concrete hardstands or protective hangars. The pneumatic tires deflated, and the landing gear struts sank into the soil over time. This subsidence brought the lower wing surfaces and fuselage bellies into direct contact with the moisture-retaining ground. The rapid overgrowth of the jungle canopy encased the structures, trapping high humidity around the airframes and blocking direct sunlight that might have dried the interior compartments. On Yap, destruction was slow, constant, and patient. There was no single impact event to read, no concentrated debris field, no moment of kinetic collapse. Instead, the airframes were worn down by a daily grind: heat and cooling, roots and vines, and salt air drifting in from the coast. For any future recovery team, Colonia Airfield offered a rare, undisturbed forensic grid. Each A6M still marked the final operational choices of 1944. But the same isolation that spared the wrecks from bulldozers left them sitting low in wet soil, where water pooled and salt-laden humidity never let go. The shapes could remain recognizable while the structure quietly dissolved. And the question was no longer identity, it was metallurgy. The legendary range and maneuverability of the Mitsubishi A6M came at a strict engineering cost. The fundamental design trade-off was extreme weight reduction. This singular priority dictated the precise metallurgical breakdown of the abandoned airframes on Yap Island. To achieve an unprecedented strength-to-weight ratio, Japanese aviation engineers relied on high-strength aluminum alloys, including extra superduralumin in critical load-bearing members. Extra superduralumin was an aluminum alloy system strengthened primarily with zinc and magnesium, with copper also present. While extra superduralumin provided the vital structural rigidity required for complex aerial maneuvers, it possessed a severe chemical vulnerability. It was highly prone to intergranular corrosion when exposed to a continuous marine environment. The vulnerability was an acceptable risk for a frontline fighter with a short expected combat lifespan, provided it received rigorous maintenance. During factory assembly, many internal surfaces were given a translucent anti-corrosion coating, often called AO-take. That layer, together with paint, sealants, and routine maintenance, helped slow oxidation and moisture attack in service. However, the moment these airframes were pushed to the margins of the airfield and abandoned, that protective cycle ended for good. Left exposed to the relentless tropical salt air and the high humidity of the jungle floor, the varnish inevitably broke down. Once that barrier failed, corrosion accelerated on both the hidden interiors and the exposed skin. Intergranular attack worked along the alloy's grain boundaries, driven by zinc and copper-rich chemistry and salt moisture, so strength could be eaten away from within, while the surface still looked intact. That mismatch between appearance and capacity was the expedition's central hazard. When the recovery engineers reached the wrecks, they were not looking at standard oxidized aviation aluminum. They were analyzing load-bearing structures that had undergone continuous microscopic expansion and fracturing. The visual identity of the aircraft remained perfectly intact. The iconic profile of the fighter was unmistakable among the vines and roots, but the physical reality of the metal had been entirely transformed. Establishing proof of identity was simple, but establishing proof of structural integrity required meticulous physical testing. The team had to physically map the perimeter of the corrosion to find viable lifting points. Physical inspection made the situation plain. The skin was no longer skin, but brittle foil. The Zero could still look intact in profile, yet a hand on a wing root or tail cone could punch through metal that started thin and had no sacrificial margin to spare. That fragility erased the usual recovery playbook. Factory hoist points were untrustworthy, bulkheads had lost shear strength, and rivets sat in expanding halos of oxidized dust. The team had to hunt for the few zones where the alloy was degraded but not yet gone, and accept that there would be no single confident lift. Handling structurally compromised airframes meant the team could not treat the fighters as single liftable units. With strength lost across spars, skins, and joints, in any attempt to move a complete airframe risked a catastrophic break. The only workable path was to separate what remained into major sections, keeping loads low and spread as evenly as possible. Even then, the work was slow and conservative. The team relied on broad, supportive handling and improvised bracing to keep fragile structure from folding as it was brought out of the overgrowth and prepared for shipment. Once loaded onto the vessel, the dismantled sections were transported from the Caroline Islands back to Japan. The arrival of the airframes initiated a highly complex engineering phase. The goal was to yield stable static museum displays, but the inventory of viable parts was heavily fragmented. No single aircraft possessed enough intact structure to stand on its own landing gear without collapsing. The damage was too severe and the metal was too thin. To solve this critical material deficit, the restoration team at the Kawaguchiko facility implemented a rigorous airframe cannibalization strategy. This component merging logic was not a random swapping of parts. It was a calculated forensic puzzle. Engineers mapped the structural survivability of all retrieved wrecks alongside additional acquired scrap. They cataloged which wing spars, fuselage ribs, and internal brackets retained their original load-bearing capacity. If the port wing of one fighter was structurally sound but its starboard wing was powder, they detached the viable wing and permanently grafted it to a solid center section from a completely different serial number. They redistributed the surviving mass across the project and systematically consolidating the strongest surviving geometries. By sacrificing the most degraded airframes, they transferred their remaining viable components to reinforce the most intact baseline structures. Executing it meant years of careful fabrication and reassembly. Over roughly 2 decades and beyond, technicians removed unrecoverable metal, neutralized corrosion traps, and spliced surviving ribs and spars into stable skeletons, often requiring multiple source wrecks to build one continuous shell. Alignment had to be documented and preserved. Mating surfaces, rivet pitch, fastener patterns, and plate thicknesses had to match original factory practice. An even static center of gravity balance mattered if the landing gear was to stand without buckling. In the end, scattered, compromised piles became coherent museum airframes. But cannibalization has a hard limit. As the strongest pieces were absorbed into the headline displays, the remaining inventory collapsed toward a deficit until one final airframe reached the end of the parts ledger. The choice between a cosmetically perfect modern replica and an authentic internal skeleton defined the final phase of the Japanese restoration project. As the component merging logic consumed the best surviving material from the recovered fleet, a hard boundary was reached. The restoration team evaluated the remaining inventory and confirmed a severe material deficit for the aircraft identified as construction number 92717. This specific A6M2 fighter lacked enough viable original aluminum skin to form a complete aerodynamic shell. The engineers faced a definitive operational crossroad. They could manufacture entirely new metal panels using modern sheet aluminum to simulate the original exterior, or they could halt the skinning process entirely. In practice, construction number 92717 had already served as a parts donor for other restorations, leaving too little original skin to close the shell. It was ultimately reassembled and displayed unskinned, turning absence into an anatomical record of the airframe's internal logic. This anatomical proof display converted a critical lack of material into a permanent forensic asset. By leaving the exterior off, the resulting skeleton physically maps the internal weight-saving geometry of the Japanese fighter. The unskinned airframe serves as a three-dimensional blueprint of the original Mitsubishi engineering constraints. The exposed skeleton reveals the extreme use of lightning holes, stamped through every transverse frame, wing rib, and longitudinal stringer. Removing this internal material reduces the overall mass of the aircraft to meet strict performance requirements, while the remaining metal web preserves the required shear strength to transfer aerodynamic loads through the airframe. The size and spacing of these circular cutouts demonstrate the precise calculation of stress margins, proving how close the designers operated to the physical limits of the alloy. With the outer skin gone, the machine's logic becomes readable at a glance. Control runs to the tail, fuel bladder mounts, the engine ring, and rivet lines that normally hide behind paint. In a stressed skin monocoque, that missing envelope matters. The structure has to be aligned, supported, and stabilized so it can carry its own weight without sagging. Displaying construction number 92717 as a skeleton was a deliberate trade, structural truth over cosmetic completion, and a permanent record of what the jungle took away. It points back to the moment the wrecks left Yap for good. Removing the wrecks from Yap preserved what was left of them, and it marked the end of a permissive recovery window on the island. After the consolidation effort, the museum distribution in Japan was precise. 3 displays remain at the Kawaguchiko facility, which officially opened in 1981. The complete A6M2, construction number 91518, the A6M5, construction number 1493, and the intentionally unskinned skeleton, the 4th aircraft. An A6M5 identified as construction number 4708 was transferred to a Mitsubishi-affiliated museum in the Nagoya-Kamaki area. Securing these 4 specific construction numbers required extracting them just before a permanent legal boundary fell across the Pacific. Today, Colonia Airfield sits under heritage protection. Modern Yap and Federated States of Micronesia rules generally restrict disturbance or removal of historic wreckage without authorization, shifting the site towards survey and documentation rather than extraction. Whatever happened in 1980, the era of casual private jungle recovery has largely given way to regulated preservation. Any modern assessment of the Colonia Airfield wrecks is survey only. Teams can document photogrammetry, measurements, coordinates, but they cannot intervene. No lifting, no cutting, no rescue of collapsing structure. The airframes are legally fixed in place, protected from people, and left exposed to the same climate that is still dismantling them. This legal reality creates a stark divergence in the timeline of the Yap Zeros. The 4 airframes extracted to Japan now reside in highly controlled, stable museum environments. Climate control can slow further corrosion dramatically, stabilizing the remaining original metal in a far more benign environment. Deterioration is not magically erased, but its tempo can be pushed down to a crawl. In contrast, the wrecks left behind on the island continue to suffer from the preservation by isolation that initially spared them from wartime destruction. The continuous exposure to the tropical salt air ensures that the remaining aluminum skin will continue to flake and dissolve. Without the possibility of physical intervention, the surviving structural frames in the jungle will eventually lose their remaining shear strength and collapse completely into the earth. The site is transitioning from an intact aircraft graveyard into a purely archaeological footprint. The remaining metal is slowly being reclaimed by the exact environment that the original expedition raced against. The ultimate legacy of the initial recovery operation is heavily defined by this closed window. The 4 museum airframes represent a finite, unrepeatable physical record. They may represent some of the last intact examples pulled from that specific airfield under today's preservation expectations and legal climate. The success of the Harada expedition is measurable by the stable, documented condition of construction numbers 91518, 1493, 4708, and the unskinned skeleton. These static displays provide a permanent physical baseline, proving exactly what was engineered during the war and serving as the direct control group against the steadily dissolving wrecks left behind in the jungle.